guys, we are going to take some notes, and I feel like I haven't seen you in a while. So go ahead and open your math notebooks, and we can label today's notes 6.1 ratios. 6.1 ratios. Okay, so let's talk a little bit about what a ratio is. So a ratio is comparing two quantities. And a word I want you to know so that if I use it, you understand it, is the word terms. So I want you to write the numbers in a ratio are called terms. Okay, and this is really a word that you are going to see all through 7th and all through 8th. And I remember some of my 8th graders, I would say terms, and they'd be like, what are you talking about? So kind of make sure that you know this word because it's something that's going to come up again and again. Instead of saying the numbers, we're going to say the terms. And the reason that we have a whole nother word than just numbers is because in algebra, we're going to have X's in there. And so it wouldn't be accurate to call them numbers. So we're giving you this word terms now so that later when we have to say terms because numbers won't make sense, you have this word. Okay? So in a ratio, we're comparing two quantities. So it might be a situation where they say 5 dogs. Remember, if I write, you write. 5 dogs to 3 cats. Okay? So if they gave us the situation, 5 dogs for every 3 cats, that means if there's 10 dogs, there's 6 cats. It's kind of like a fraction. So to write this as a ratio, we could write it 3 different ways, and you need to know all 3 ways. And let me just tell you, order is everything. So if they say dogs first and cats second, then everything I write after there keeps to that order. So we could say 5 to 3. That's one way. We can say 5 to 3. Now I know I said it the same way, but look, I wrote it a different way. Okay, but it would be said the same way. And then we can say it like this, 5 to 3, or I guess write it like this, or 5/3. Now notice, in these two examples, 5 comes first, 3 comes second. In this example, 5 goes on the top. Okay, so the number that we want to say first is on the top. Kind of like if I say 1/2, I put the 1 on top. This is 5/3, so I put the 5 on top. These all represent the ratio of 5 dogs to 3 cats. Okay, so comparing two quantities, and remember we call these terms. All right, if you need to write that and catch up, do that because I'm about to erase. All right, so when we do ratios, we can do 2 options, part to part or part to whole. Okay, and that's the comparison. So we could compare 2 parts of, let's say, the pet store. There's 5 dogs and 3 cats. We could also compare part to whole. So we could say there's 5 dogs to every 8 animals. Okay, so did you hear the whole? And this can be switched. We could say for every 8 animals, there are 5 dogs. So these 2 words can be switched. So let me show you another example so that this makes sense. So please write with me. We're going to write a little table. So we're going to pretend we have a bunch of movies. We have comedies, we have dramas, we have cartoons. I guess that could be a movie. And we have science fiction. I'm going to write sci-fi. Okay, we have 8 comedies, 3 dramas, 2 cartoons, and 1 science fiction. Okay, so these are our terms that we're going to work with. And then you're going to have a question that tells you to compare comedies to dramas. And like I said, order is everything. So we take the number of comedies, 8, and we compare it to the number of dramas, 3. And to write it 3 different ways, we can also write 8 to 3, and we can write 8 over 3. So it's all 3 ways that we would write that. It's just a comparison. For every 8 comedies, there are 3 dramas. Okay, and that's 3 different ways to write it. If you can't see this very good, this is a colon. Okay, so this is part to part, a part and a part of the whole. So this second one I'm going to do falls under this category of part to whole. So they're asking us to do dramas to total. So dramas, we know there's 3, 2. And when they're asking us for the total, we want to add up all the movies that are totaled here. So 8, 9, 10, 11, 12, 13, 14. So 3 to 14. We can write it like that, we can write it like this, and we can write it like this. Okay? And you have to keep to the order. They said drama first, so we wrote the number that goes with drama first or in the top of the fraction, and then they said total second. And you have to pay attention to when they say total because that's requiring you to now add all of your options up. Hopefully this is making sense. Let's keep going. If you need to, pause it and catch up on your notes. All right, so I want you to try this one. I want you to try this one, okay? So we have a party mix. It's kind of like your Chex Mix if you've ever had it. So party mix. And in this mix, we have 3 cups of pretzels. Remember, if I'm writing, you're writing, so I want all this in your notes, please. You have 3 cups of bagel chips. This is sounding delicious. We have 1 cup of cheese crackers. I don't know about the cheese part, but crackers sound great. And 1 cup of peanuts. Okay, so here's our party mix. And this is the ratio that we have to make the party mix in. So if I want to make enough for the serving size, this makes 8 cups, by the way. So if I want to make enough for the serving size, I would pick this ratio. But we're going to talk about what happens if we, and this is kind of what we've done before, if we had to quadruple it or double it and make more. We don't want to, we want to double or quadruple all of these amounts so that it would still have that ratio of pretzels to bagel chips or pretzels to crackers, pretzels to peanuts. Okay, so you know you've heard that word before because that's what we're doing. Okay, so I want you to try, let me see. I want you to tell me on this one, bagel chips to peanuts. So bagel chips to peanuts. I want you to tell me total, okay, total party mix to pretzels. And I want you to try, remember you're writing these 3 different ways, cheese crackers to peanuts. Okay, so pause and you try. All right. So bagel chips to peanuts. Bagel chips are 3, 2, and peanuts are 1. And we could write that 3 to 1, 3 to 1, or 3 over 1. And because it's a ratio and we're comparing 2 quantities, you can't just turn a 3 over 1 into 3 for this math like we do in other situations. You have to leave the over 1 because we're comparing 2 things. So that's really important in ratios. Okay? All right, total to pretzels. So the total is, now they told us 8 cups total, but if you forgot that, you need to add up all of this. So 3 plus 3 is 6, 7, 8. And they said total first, so I have to write 8 first. So 8, 2, and pretzels is 3. And I can also write it like this, and I can write it like this. All right, so keep checking yourself. Lastly, we have cheese crackers to peanuts. Cheese crackers is 1, 2, and peanuts is 1. Okay, so 1, 2, 1, and 1 over 1. And you'll hear in a recipe them tell you, like you'll see in the recipe, it'll say 1 to 1. Okay? When you see that, that means another word for it, and I want you to write this down, is equal parts. Okay? Equal parts. If I have a cup of cheese crackers, I have 1 cup of peanuts. Equal parts. Kind of like equal terms. They're parts to a whole, but they're equal. So you know in a recipe, if they tell you it's 1-to-1 ratio, or they tell you equal parts, you know if it's half a cup of this, it's half a cup of this. If it's 1 cup of this, it's 1 cup of this. They're equal parts. Okay? So I really think you've probably heard that term and didn't necessarily know what it meant or how it applied to math. You're going to hear that term now and you're going to think about this situation. Okay? So equal parts or 1-to-1. 1-to-1. We also say in education that someone might have like a 1-to-1 aide. That means that they have, for one student, there's one aide that's helping that student. Are our teachers 1-to-1? No, our teachers are 1 to maybe 25. So that's 1 teacher to 25 students. I'm comparing 2 things in a ratio. All right, so I am about to erase, if you need to copy any of that down. All right. Now, sometimes we have equivalence ratios. And this is something you've worked with before, but you just may not have known what it was called. So equivalent ratios. So that's like saying 2/4 is really like 1/2. It's like reducing a fraction. But we could also unreduce the fraction and double both of these and make 2 times 2 and 4 times 2. And these are all equivalent ratios or equal fractions. And so you have to be ready to see it like this, 4-8, and know that you could reduce it and turn it into 2-4. And you could even reduce that and turn it into 1-2. Okay, so this is a concept you worked with before because you reduced fractions. And there are times, like when you're getting common denominators, that you have to unreduce fractions. So just like a 2/7, we could multiply them both by 2 and get an equivalent ratio of 4/14. Okay? I am going to stop this video and start a second one just because I'm running out of the time that it lets me upload. So please think about what I just said, and then I'll be back in a second.